Okay. Good afternoon, children. Okay, children. Good afternoon, you all. So, can someone confirm me whether you can hear me clearly? Sandaru, can you hear me? Sandaru? Okay, good. Okay. We have joined, we have met earlier, and let's see how we can continue the seminar series. So, we came across 4 lessons in grade 8. So here we are doing this in order to prepare you for the final term test, the year-end term test in your schools. So I prefer if you guys can turn your videos on, and also from today I'm going to let you interact with me more. So I hope that you will join with me in order to make our lessons more interesting and less boring. Okay, so during the lessons I will ask you that to answer my questions that are not very difficult. Amaru questions you can give answers leisurely. So I hope you will join with me for the lesson. Okay, they are not questions like the questions in the examination, just to interact me. Okay, අපි දෙගොල්ලෝ interact වෙන්න තමයි මම මේක කරන්නේ. So you can ask questions in your chat too. I will try to answer most of the questions that you give me. They are the supply your feedbacks also. Okay, so we have passed a whole month of our vacation. අපේ vacation එකකින් ඔන්න මාසයක්ම ගිහිල්ලා. So luckily we have 2 more weeks rest. Okay, so we have to take the maximum use of this, because just after we start the vacation, school, after the vacation we have to face the year-end examination. So this is a help for you in order to do your studies. Okay, so last week we completed the lessons of the revision up to unit number 4. So we are going to continue with from the unit number 5. Okay, so in these units I have given a separate activity sheet in order to do. So after completing a lesson, we will discuss the questions. Okay. So are you ready to go with me? Okay, good. Good, Letumi. Okay. So our fifth lesson, that's sound. Okay. So in grade 6 also we learn about sound and even 7. So we are just repeating the same lesson, a little bit complex than grade 7. So it's just like a revision. එකක් වගේ ඔයාලට just to refresh your knowledge that you gain in grade 6 and 7 and some a very small amount of subject matter is there as me. Okay. So here. So if we talk about the sources of sound, there are 3 types of sources of sound. We categorize them according to the way that we are producing these sounds. So, අපි ඔයගොල්ලෝගේ music class එකට ගියොත් ස්කූලේ music room එකක් තියෙනවා. If we go there, we can see several types of these musical instruments. Okay, some are playing drums and flutes and guitars and all. Okay, so we can categorize them according to the vibration method of them. Let's see with whom that we can Litumi. I prefer if you can keep your videos on, then you won't be feeling lazy or mean either. Otherwise I will feel a lot lonely doing this. Okay, Bhagya is here. Okay, now you have the chance to talk with me.
Hello, madam.
Hello. Good afternoon.
Good afternoon, madam.
Okay. Can you remember how the sound is produced?
Sound is produced by vibration.
Okay, very good. The vibration of some kind of a medium is resulting the sound. Okay. So good one. Okay. So in there, here you have given the one that we are vibrating. Here the first category, they are vibrating the membranes like drums, tabla, bass drum, like that. Then vibrating air columns, all the trumpets, flutes, all those things are using that vibration of an air column. Okay, and even the serpina, and the vibration of strings or bars is used in guitar, sitar, like that, all things, and also the xylophone. Okay, so then according to the nature of these sounds, we categorize these two sounds into two as natural sounds and artificial sounds. So we can hear both these at our environment. When we are living in the environment, both these sounds can be heard. Okay, so natural sounds are the sounds that we hear from the natural environment. අපේ ගෙදර ගියොත් හැමතිස්සෙම කිචිචි ගානගෙන ඉන්න birds ලා ඉන්නවා. And these cats, they are making sounds, and even various things are there in the natural environment that make these sounds. And in the artificially, made sounds are there from the machines and vehicles and all other things. So we can categorize them according to the way the sound is being produced. Okay. So earlier, let me told that this sound occurs because of vibrations. Okay. So you know that something is there that we call as frequency of vibrations. Okay. This is called the number of vibrations of an object per unit time. Example, number of vibrations within a second. We call that frequency of that object. We measure this using the unit hertz. Okay. So the vibration frequency differs from object to object. Okay. So if we talk about animals, they have different frequencies in their voice. Okay. So let's talk about that later. And here, this is an activity you are doing at school. See, is there someone who has done that? Can you raise your hand? Is someone there? Yes. Sehas. Okay, Sehas. Now you can talk with me. Yes, tell me, have you observed these tuning forks?
Yes, teacher.
Okay. So, your science lab මේ වගේ several lengths තියෙන tuning forks ඔයාගාව දැක්කද?
Yes, teacher.
Good. So they produce different sound with different frequencies. Okay. So when you're doing this, what is your observation? Good.
The tuning fork is vibrating.
Yeah, when we vibrate the tuning fork, we get a sound. So what is the result when we use the tuning forks with longer arms?
Short arm produce small vibration.
It's not, I'm asking about the frequency of the vibration, okay? We can't measure the vibration by number. We are measuring that using the frequency, okay? So what we can tell about the frequency of the sound which is being produced by the tuning fork with longer arms or shorter arms. You can continue the answer, okay?
The frequency is high.
In which one?
The longer tuning fork.
Okay. Is that the same with the other one? Litumi?
Teacher,
Yeah. Have you got the same observation?
teacher frequency is increasing gradually by the decreasing length of the tuning fork.
Good. That's the correct answer. Sehas, when the arm length increases, the frequency of the sound it generates decreases. Okay? Remember that, keep it in your memory that when the arm length increases, the frequency that produced by these forks decreases. Okay? So the highest frequency is by the shortest tuning fork. Here, I will show you. If we give it in a graph like this, when the length increases, that frequency decreases gradually. Okay. So Sound generated by a tuning fork differs according to its arm length. Frequency increases gradually with decreasing length of the tuning fork. Okay? I hope everyone is clear. Okay. Then here. So, and also there's a mechanism there in every musical instrument to change the frequency. We learn that there are different methods to produce this sound in different kind of instruments. So first one you have given a serpina, then a tabla and a guitar. In all those types of instruments, there are mechanisms in order to change the frequency of these instruments. මේ instruments වල sound එකේ frequency වෙනස් කරන්න there are mechanisms. Okay? If someone is there who is doing music, tell me how you change the frequency of a guitar. Can you raise your hand? It's okay, Sehas. Okay, that's something very simple because everyone do mistakes, even me. So we are refreshing our memory. So this is somewhere you can learn too. Okay, so keep interacting with me so we can do this well. Okay. Sorry, so it's okay. Then, is there anyone who let's see, who is doing someone who is doing music, and anyone know how to tune a guitar? You can raise your hand. Anyone there? No one. Aha, Sanuka. Okay, Sanuka. Now you can talk with me. You can, I have sent you a request. So you can accept. Yeah. Are you there, Sanuka?
Yes, teacher.
Oh, good. So tell me how we tune these instruments. If we take an example as a guitar, how we tune that? Aha, good. You have a guitar. So how we are going to tune that? Yes. Okay. By that, how you are doing that? What is the result of those movements?
Having a half sound in strings,
Yeah.
having a sharp.
Yeah. What are you doing there? We end the string.
Increasing the length of strings.
Sorry. Can you tell?
Increasing the length of strings.
Okay. When you increase the length of these strings, what will happen to the frequency?
Increase.
No, dear. We talk about that. When the length of the strings increases, that frequency decreases. Okay? Because they have there's a difference in there. As we talk about it in this graph, when the length increases, the frequency keep decreasing. Okay, so by tuning the guitar, when we change the length of that strings, that the frequency that it makes decreasing. So if we want to tune that into a higher frequency, අපිට high frequency එකකට මේක tune කරන්න ඕන නම් we are just tightening those strings. So by tightening, the length of that strings get reduced even a small length. So that increases the frequency of the guitar. Okay, and you know, even the smaller strings in there, they produce a higher pitch sound. අර චූටිම හීනිම string එක guitar එකේ තියෙන ඒක produce කරන්නේ ඒක high frequency sound එකක් තමයි very ඒක produce කරන්නේ. Okay, so that extent, talking about that extent is good, is enough for you. So here you have given the idea about how the tabla is tuned. Okay, so musical instrument that produce sound by vibrating membranes, their frequency increases when the membrane is stretched more. Okay, so by doing, they are doing by these parts, the wooden blocks, they push them downwards, and by that this membrane gets stretched. When the membrane gets stretched more, the sound that makes by them increases. Okay, so when that sound of that makes by the tabla එකෙන් එන sound එක high frequency එකෙන් නැති වෙලාවට music teacher can identify that and they stretch that more and get it tuned. Okay, then the flute. Here, the musical instruments that produce sound by vibration of air columns. Okay, there you know, flute එක play කරන්න දන්න කෙනෙක් ඉන්නවද එතන? Is there someone? If you raise hand, good, Sadev. Okay, now it's your time. Tell me, how you play those notes? Can you answer my question? So just share your knowledge. Okay, I'll tell you. Okay, so in the flute, if we close the holes in the front and open a hole at the other side, I will use the board. Okay. Can you see the board? If it's a flute like this, we have that hole, the big hole from there where we insert air is here, and there are some other holes in here. Okay, so if we close all these and only leave this one, the air column can vibrate up to this length and comes out from here. So the length is high, so length is larger, so the frequency is lower. So if we open the hole here instead of this, only this length of the air column can vibrate and come up from this. So the length is smaller. Then the frequency is higher. Okay, so in the flute they are using that phenomenon. Okay, and here this is a local product that they are using like a flute. Okay, they have this the different length tubes, so they can produce different kind of music with different frequencies. Okay, sorry. Okay, so a musical instrument that produce sound by vibrating strings. So most of the musicians use this guitar, just like our friend, okay, who is using the guitar. So we do this vibration by strings or rods. Let's see. Here, a sharp sound will be generated by vibrating short, tight, and thin wires. Okay, all these features help in the high frequency sound. Short, so tight and thin. So by tuning the strings of the guitar and violin, we make it short and tight. And even among those strings, the thinner wire get the highest frequency. So the low frequency sound is resulted by long, loose and thick wire. Okay, and also high and the way that it played and the speed of vibration also can change the sound that it makes. Okay, let's see. Ritumi is only there with opened videos. Okay, so so Sadev, I guess he is the one who played the guitar, isn't it? Sadev. I'm not clearly remember. Okay, so when we play the guitar or violin with a high speed, it gives a different sound rather than playing it in a very lower speed. Okay, do you know that? So let's move. So in here also there's another instrument called xylophone. So it produces sound by the vibration of these plates. Okay, so in there also there are plates with different lengths. So the shortest plate make highest frequency and the longest plate produce lowest frequency. Okay, so the summary is that so here our summary long thin and stretched. Yeah, there's a term for that. Yeah, tight. Sorry, long, long, thick, and loose ones produce low frequency. You will get this මේක ඔයාලට ඉරි ගහන questions relate කරන equations වලට ආන්න පුළුවන්. So short and thin and tight one can produce high frequencies. Okay, it's a summary. So let's move to here musical tones and noises. Okay, since grade 6 we heard about that. So there should be a frequency, a tone there in musical tones and Noises are just scattered frequencies. Okay, so here these noises are not comfortable for our ears, but these musical tones are very comfortable for our ears. So we love music, but not noises. Okay. Here, ancient, traditional, and modern music instruments. Here, these are the ancient instruments. Here, like sitar, veena, all those things are ancient parts. And here we have the traditional music instruments like dolki, raban, tabla, and all those things. And there are modern instruments like electric guitar, organ, like that. Okay. Okay. Is there anyone who has these modern musical instruments? Anyone who like to talk about this? Someone who can play these modern musical instruments? Is there anyone? Pamuduni, can you play any musical instrument? I can play the piano. Sehas. Good Sehas, okay? Can you play any musical instrument, Pamuduni? It's okay if it's not. Just talk with me.
Can't, teacher.
It's okay. We can even make a drum from the table, so we can make a music from there. If it not become a music, it will make a noise even. Okay. Matad bahe. When me can't do that, so the way that I try to make music, it produce noise. Okay, so that's okay. Well, madam, can you give me 10 minutes? I have no idea why. You can join with me again, okay? Yes. Here. Music therapy. This is something interesting and something new for you. Okay? Musical therapy. Music. You know that people have got used to listen music when they are feel a bit of stress and bit of boring and before going to sleep. So they have make it a habit, and rather than apart from the people that there are some others they are doing that as a subject and their leisure time activity and all, but some are there they are just listening to music just like me. Okay, so this has been introduced as a therapy, especially for the people who are having terminal illnesses. Do anyone know about these terminal illnesses? This is kind of a general knowledge actually. Okay, let's see. Good, Bhagya. Can play violin. Okay, if you are ready to play, I will give the chance a small part. So let me know. Any guitar, good, Abhay. Okay, I can give someone a small chance to play even for a minute. Okay, let me know. So, do you know about the terminal illnesses? Anyone know about that? So, Yeah. Anyone who knows about the terminal illnesses? Litumi, do you know?
No, teacher, I have not idea about that.
Good. Okay. Do anyone has Yenushi? Say answer. If you have an idea, just raise your hand, okay? For the questions that I ask, if you know that, just raise your hand, okay? So I will discuss a little about the terminal illnesses here. That's good for your general knowledge, okay? Terminal illnesses means they are not the like dengue, malaria, they will get died within a very short time if it go into complications. Terminal illnesses are not like that. Cancer is a very good example for these terminal illnesses. Every type of cancers, because cancer that has gone to an extent that it cannot be cured. Okay, there are people that they discovered as a cancer patient, but when it's discovered, they have gone to a level that they cannot be cured 100%. Okay, so 100%ly cure කරන්න බැරි extent එකට ඒගොල්ලෝ ගිහිලා තියෙනවා. So then they have to live until they reach the death. So they have to live with the fear of death. මම මැරෙනවා, but when? So they are getting that stress into their mind. Okay, so in order to calm their minds, to give them a happy life until they die, these musical therapy is used. So diseases and disorders of brain and nerve system, they are also a kind of terminal illnesses. Okay, brain disorders and the problems in nerve system, there are some serious complications which usually leads to death. Okay, death in a shorter period. And heart failures, and especially this musical therapy is used for mental depression. Okay, and also for the people අපි වගේ දැන් generally අපි වැඩ කරලා ඉන්නවා, even for us we get stress at from studies and economical crisis. We get this mental stress. So this musical therapy can increase the physical fitness of the body and also the mental integrity. So we have to be interacted. Okay, so Bhagya is ready. So let's see, where is Bhagya? You can put your, yeah, I'll unmute you. So now you can play. Yeah. A small part, okay? Good. So she produced sound. She produced music, actually. It's not noise. It's music to vibrating strings. Okay. So let's see something. I was like blabbering continuously. Let's see something. Okay. Hmm. Wait a little, darling. Okay. This is about the therapy that they are giving for that kind of hospice patient. That means who are suffering from terminal illnesses.
Everything I do that I walk in is for a purpose. There's a reason. And when a patient isn't feeling well, that's the moment that we want. That's the moment where we can provide the most effective. And I'm constantly assessing as the session goes on how I can change, how I can use it to help this need. My name is Erica Santiago, and I'm a music therapist with Vitas Hospice. You know, when I first heard of hospice, I thought patients that can't communicate, they're literally on their deathbed. Yes, I have patients that are actively dying, but most of my patients can talk to me, they laugh, they make jokes, you know, they're actively engaged in their everyday. It's just that they have this terminal illness that, you know, they can't do anything about. I think that's what's difficult in wanting to accept hospice. They don't know what it's going to be like. They don't want someone coming in, crying, how are you doing? How are you feeling? You know, how are you coping with this? It's overwhelming. With music therapy, it's non-intrusive. I can get the same answers without asking those questions. Music is a universal language, and I'm coming into your home and I'm bringing something that everyone can connect with. And a lot of times it's validation. I see you, I'm here with you, and I'm acknowledging what you're going through, and I'm here to help.
Did you see the video?
In any way that I possibly can. I think that everyone
Sorry.
has
So,
therapy to themselves with music. And I wouldn't say that it's music therapy, and it's not.
oh. Can you see now? Can you see a video playing in there? Good. Thank you.
And when a patient isn't feeling well, that's the moment that we want to be there. That's the moment where we provide the most and be the most effective. And I'm constantly assessing as the session goes on how I can change, how I can use the music to help this need. My name is Erica Santiago, and I'm a music therapist with Vitas Hospice. You know, when I first heard of hospice, I thought patients that can't communicate, they're literally on their deathbed. Yes, I have patients that are actively dying, but most of my patients can talk to me, they laugh, they make jokes, you know, they're actively engaged in their everyday. It's just that they have this terminal illness that, they can't do anything about. That's what's difficult in wanting to accept hospice. They don't know what it's going to be like. They don't want someone coming in and hoping and crying, how are you doing? How are you feeling? How are you coping with this? It's overwhelming. With music therapy, it's non-intrusive. I can get the same answers without asking those questions. Music is a universal language, and I'm coming into your home and I'm bringing something that everyone can connect with. And a lot of times it's validation. I see you, I'm here with you, and I'm acknowledging what you're going through. And I'm here to help you in any way that I possibly can. I think that everyone does therapy to themselves with music. But I wouldn't say that it's music therapy. And it's not only because I'm bringing music, but I'm bringing that interaction. And the therapist is a huge part, if not more than music, because it's a personal level, it's a relationship with our patients and their families. And bringing a human element into that is the biggest part of what music therapy is, so that we can match what the patient needs and respond accordingly. Great. How does it make you feel?
Okay, children. So I hope that you got a small idea about how this musical therapy can be used for these people in order to cure them, just not to cure them, just for their good health and for their mental integrity. Okay, so yeah, then it's a final part of the unit, limits of hearing. We cannot hear the whole range of frequency that they have sound by the sound. There's a large area for the sound in the electromagnetic radiation. You will know about that, learn about that in the higher grades. So we cannot hear that range. If we hear that, we will go mad. Okay, today we hear from the humans, limits of hearing is from 20 hertz to 20,000 hertz. If we keep hearing lower frequency in that land and higher frequencies, just from this second, we will totally go mad. Okay, because we will hear a sound of these not mosquitoes, the ants talking. Okay, if we have to find something like that, we would not concentrate into any of these. Okay, so limits of hearing, that the limit is the range of frequency that we can hear. So this range of frequency differs from animal to animal. So dogs has a higher frequency range. They can hear less than 20 hertz and more than 20,000 hertz, greater than us. Bats can hear up to the level of 70,000 of hertz. Okay, you know that they can communicate and they can even in dogs, when we are very far away from the place, they can identified that we are coming from the sounds. Okay, so that is why we told that the range of frequency of sound by the limit that we hear differ from animal to animal. So that's the end of our lesson. So let's move on to the questions that we have. Have you gone through the questions paper? Okay. Okay. Hope you can see this. The paper. Have you done that? Tarushi Pabasara. Did you have time to go through that, dear? It's okay if you have not done, just talk with me.
Teacher,
Yeah. Have you done the activity sheet? It's okay. Let's keep doing that. Okay. So the first question from unit number 5, which statement is incorrect regarding sound? The first one, sound is produced because of the vibrations of objects. Sound is created either naturally or artificially. Objects that create sounds are called sources of sound. The frequency of the sound that creates when the membrane of a tabla is stretched is lesser. So, who are going to answer me? Binuti, can you answer me? No, I'm just asking from there. If someone is there who can answer, raise your hand. Otherwise, just reading the question by me and just the answer again by me would be really boring for you. Okay, this is something that have been given by this institute in order for you're good, because you will get the maximum use if you following the lesson and doing these activities. Okay, so good, Vinuti. The answer is number 4. You can put that in chat too. Okay, otherwise it will take some time, more time, if we try to communicate in the in voice in the while doing this paper. So the fourth answer is correct. So the second one, what is the frequency of a substance which produce 50 vibrations in 10 seconds? Third says, I guess that in the unit you have not given much about this calculation. This frequency means the number of vibrations that produce within a second. So the answer is number 2 for the second question. Pamuduni, you are correct. Now the following diagram shows an instance of hacksaw blade tightly fixed in its lower end of its middle position is A. The distance mouse is in one vibration is one vibration. What is it? From A to B, or A to B to C to A, or A to B and again C, or from B to C to A. The total vibration that gives the frequency It's from A to C to B and again coming back to A. For the question number 3, the answer is number 2. Okay, the one from the name Charita. If you are answering for the third questions here, that should be number 2. Some of the statements about musical tones are given below. Who will be answering this? Some of the statements about musical tones are given below. It will never be oppressive. It will be rhythmic play. It is used to promote quality of life. The correct statement from the above are: it will never be oppressive. That can happen about noises. Oppressive, it will be rhythmically played. It is used to promote quality of life. All the 3 are correct and that the answer is number 4. The 5th one, select the correct statement. Music is created through the regular vibrations. That is correct. The frequency of a, keep that aside. The frequency of a frequency can be changed by changing the length of it. Yes. The frequency of the biggest wire in the guitar is high. That is wrong. Human ear is audible to any frequency. That is incorrect. So, the correct answer is number 2. I hope you will put your answers on the chat. Can you repeat the answers 2 and 4? For the second one, it's 50. That means the answer number 2. And for the fourth question, that is, the answer is 4. Okay? Okay. In this, I will just try to discuss the first question. A group of grade 8 students displayed more instruments in the laboratory to check the frequency of vibrations. Diagram of the source of sound is given below. Identify the above instrument. What is this? Is there anyone who like to discuss these answers with me? Just good, Abel. That is tuning fork. If there's someone, just raise your hand, okay? Then that will be good for you since this is for the good of you. Which of the above instruments has the highest frequency? Among these two, which one has the highest frequency? If you keep, yeah, the B. This one, the shorter length tuning fork. Name the unit which is used to measure the frequency of vibrations. What is that? That is hertz. What do you mean by music and noise? What is music? I'll let it in order to type that in your chat as the answer. You know what is music and noise, the difference. Just write it in your chat, then we can discuss. Okay, let's move to the next one. This is the structure of a musical instrument which can be made easily. Then how does this musical instrument produce sound? This produce sound by vibrating these strings. Okay. Name another 2 musical instruments that produce sound like that. This is a kind of a sample guitar. So like that, violin, sitar, like that, those they can produce sound like just like this instrument. Write how the frequency of the sound is made by the musical instrument changes in each of the following instances. No one is giving me the answer for the last question of the last question. What do you mean by music and noise? Write how the frequency of the sound is made by the instruments of each of the strings. When the vibrating length of the strings get decreases, what happens? The frequency increases. Okay, when the length decreases, frequency increases. By increasing the amount of tension of strings, increasing the tension when they become tight, that also produce higher frequency sounds. Try two other ways how sound is produced from musical instruments. By vibrating, good, air columns, and by vibrating membranes, good. Write one example for each. By vibrating air columns, example trumpet, flute, etc. By vibrating membranes, drum, tabla, and so on. Okay, that's all for our lesson number 5. So then we are going to move on to the next one. Okay, magnets. Yes. Is there something here? Yeah, there's a video there. Let's go on. After just roughly go through them, you know that this is a repeat of grade 6 and 7, but we'll talk about it quickly because some extra subject matter is there. Okay, so the magnets. So in here we are talking about magnetic materials. So the magnetic materials are the materials that attract towards magnets. We learn about magnets. So here the magnets, they are steel magnets and some are made up from ferrite. Okay, so there are materials which attract towards these magnets. Example, iron, nickel, chromium, alloys like steel and ferrite. Okay, so among these, the magnets are formed by steel and ferrite. So, and in a magnet, there are poles. Poles are the regions where magnetic power is concentrated. Okay, it's going to talk with me. This magnetic power is not distributed equally in everywhere in a magnet. Okay, higher magnetic power is concentrated in the region, the two ends of the magnet. We call them North Pole and South Pole. Okay, they are situated in different places in different magnets. There are a lot of shapes of the magnet. So in there, these poles are situated in different areas. Okay, the common example we know is what is this? What is this magnet? It is bar magnet. Then identifying a magnetic pole. So in order to identify the poles of a magnet, whether it's the north or the south, like this magnet does not mark it there, the poles are not marked. So we have to identify the poles, whether it's north or south. We can use different methods. The first one is the easiest method is using a compass. And the second one, considering the direction of a magnet turns when it's hung by a thread. You know, when it is freely hung, there are directions situated from the geometrical north and south. When we hang them in freely, they are north and south placed as the same of the the north and the south of the earth magnetic field. So we can identify that. And considering the direction that magnet turns when it is floated on water using a piece of cork or styrofoam. We have done that in grade 6 too. And observing the attraction or repulsion when a magnet with known poles is brought closer. Okay, we take them near and see whether what pole attracts with the north pole and what pole attract with the southern pole. So that we can identify it using that. Okay, and when kept on a watch glass and move freely on another watch glass like this, we can identify that. This is the magnetic field of a magnet. That is the area that the magnetic power is spread around the magnet. So there are patterns between unlike poles. So there's an attraction. So these iron particles are placed like this. When it is like poles, they are distracting. So they are placed like this, the magnetic field. Okay. So the compass. We told that we use this instrument in order to find the direction. From our history, we know that this is used by the seamen in order to find the directions. Okay, so this has a magnetic needle. Here, this is a magnetic needle. So it can float very freely. This in a compass, there's a liquid there. So this needle can float freely. It's only attached from here. It can turn freely at a pivoted point. That means this point. Okay. So, it is the direction of magnetic field is from north pole to south pole like this. You learn this in grade 6 and 7. So, how that our compass works is like this. It is placed to the north and the south of the poles of the magnetic poles of the earth. Here, this is called the geomagnetism. There's a magnetic field near the earth crust. Okay, because in the earth, you know that in grade 7, have you learned about the layers of the earth? Can you remember? I have to ask someone, otherwise I'm getting bored. Imaya, just talk with me, Imaya. No.
Yes, teacher.
Good. Okay. I hope that you learn about the composition of the layers of the earth. Can you remember? There are 3 major layers of the earth. The innermost layer is the earth core. In the grade 7, that's the 8th lesson. Okay. So in there, it's composed of metals. Totally, its composition is metals. So in that layers, they have they are in a liquefied medium. They are not in as solids. Solid විදිහට නෙමෙයි තියෙන්නේ. They are as liquid because there's high temperature and pressure in those areas. By exposing to that high temperature, they are liquefied. Okay, so after becoming liquefied, they circulate in the earth. Okay, these liquefied metal currents circulate around this earth core. So due to the movement of these metal currents, electricity is generated. Okay, due to these metals, you know that the metal movements can result these magnetic properties. So there's that electric currents can be produced, so that results this geomagnetism. So that is a magnetic property, and this magnetic, the north of the geomagnetic field of earth is not the true north of the earth. Here, this is the true north. It's not the same as the magnetic north. So this axis is a bit of shape. That means make පොඩ්ඩක් අපි කියනවා හැරිලා තියෙන්නේ. Okay? So it is a bit far from the true north. Okay? So we can see that this magnetic field is spread from this magnetic north to magnetic south. Okay, so in talking about magnets, there are temporary magnets and permanent magnets. So especially in making electromagnets, is there anyone who has made these electromagnets, who tried to do this or made this at school, the electromagnets? Just raise your hands. Who has made these at school? Good or mean? Abhay, good. Seansa, good. You have made them. So it's a simple process. Okay. You can just take a coil of copper and wrap that in this kind of nail and join them to a battery, and after keeping for a while, this act as a magnet. It gets that magnetic property. Okay. So when we stop the electric supply, then it loses that magnetic property. So the magnetic power remains only when electricity is supplied. Electricity supply කරලා තියෙන වෙලාවට විතරයි they show this magnetic property. So we call them temporary magnets. Okay, but there are permanent magnets like the bar magnets, U shape and horseshoe shape, like that kind of magnets. So in there, magnetic power remains for a long time, not for ever. Okay, the magnetic power, they lose that from time to time gradually, but it remains for a long time. So we can make a permanent magnet. Okay, so how to make that? We can make electromagnets easily, but how can we make it a permanent magnet? We need these things: soft iron. Okay, the electromagnets and other temporary magnets are used by this, and steel or ferrite. This, in order to make permanent magnet, the soft iron is not enough. It can be used only to make electromagnets and other temporary magnets. In order to make permanent magnets, we need steel or ferrite, and to make permanent magnets in a bit of power. But if we need to make more powerful permanent magnets, we have to use this ferrite. Okay, here this is an example for an electromagnet, and here the permanent magnets with steel, and these kind of a bit of large permanent magnets, they are made from this ferrite. Okay, the metal ferrite. So here the construction of permanent magnet. Let's see how we can make that.
today's video, I'd like to show you.
Sorry. Can you see this? Just let me know that in order to confirm that you can. Yeah, that's good. Okay.
How to make a simple electric magnet. You may recall this experiments from your physics class or crafts lessons. So let's start. We will need a copper wire, some electrical tape, one AA battery, one nail, scissors, and some pins for testing. First of all, let's wrap the copper wire around the nail. Like that. Make the coil as tight as possible. Now back up the excess. Now strip the insulation. Then connect to the contacts. Gotta be some tape. And as it goes, one to the minus, and one to the plus. And so we get such an electrical magnet. Let's test it out. Well, thank you so much for watching. Don't forget to subscribe, leave comments, and press like. Thank you one more time.
Okay. And that is the electrical method. Then let's see about the contact method. Okay.
Single touch method. Place a soft eyepiece AB to be magnetized on the table. Take the bar magnet and place one of its poles on the soft eyepiece as shown here. Stroke the soft eyepiece with the bar magnet. When the magnet reaches B, lift it and place it back to the position A and repeat the process several times. The upper side of the soft iron gets magnetized. Now turn the soft iron bar as shown here and magnetize the lower side in the same manner. The point A will get the same polarity as the pole of the magnet touching it, and the upper end of the bar will attain the polarity opposite to that of the magnetizing pole. Test for magnetism. Place some iron nails on the table. Now bring the soft iron piece near the iron nails. The soft iron piece attracts the nails, showing that magnetism is induced in it.
Okay. Hope you understand that that is the contact method. Simple touch method is called the contact method. Okay. So that is the way that we can construct these permanent magnets. Okay. These permanent magnets, I told you that they get aged. That means that they will lose this magnetic power. The first reason is that aging. By time to time, they lose their magnetic power. And also, some external factors also affect this, like being subjected to high temperature and other strong magnetic fields and vibrations. If they fall down again and again, that they will gradually lose their magnetic power. Okay. So we have to be very careful when storing those permanent magnets. You know that they have a cost in ordering that for the magnets that we learn, that we used to learn at the laboratory also has a cost. So we have to be sure to store them well. So, okay, there's a case. Have you seen that case? In order to store them, especially the bar magnet, there are some case in order to place them well. So in there are soft iron plates at the ends of this case, and there's a wooden strap in between those bar magnets. So then their magnetic fields are not getting interacted with each other. Okay, so these soft iron plates, they use a soft iron plate and a strap of wood in between them. Okay, so we have to store them in a way the magnetic fields of these magnets do not scatter and get interrupted with each other. Okay, so finally, the use of permanent magnets. So you know they are being used in different instruments, in loudspeakers, small electric motors, the ones that you use to for many inventions from your little ages. Okay, in some door locks, pencil boxes, and the stickers on refrigerator. You know the phone covers. I also have that kind of a phone cover, and bags, some toys, and also in a compasses. In compasses, we talk that there's a small needle of a needle shape magnet is there. Okay, so yes, yeah, that's an experiment. Okay, that's the end of our lesson number 6. Okay, and while you are doing this, for the next day we have one more lesson to do as the revision series continue. I guess it's on next week, so you can suggest what are the units that I will try to cover the unit number 8 to today. If we have time, let's just go through the unit number 9 too. From the rest, what are the difficult units that you need to talk a little bit more among the unit number 10 to 15? Okay, some units are there that you can just keep studying and just they will come to our memory and they are easy. But there are some units with different concepts and some more subject matter in there. So let me know about your preference. So I will consider that also when I'm planning my next lesson. Okay. So before moving to the lesson number 7, let's just look at our question paper. Okay. So use your chat to put your answers, please. Okay. The first one, magnetism is a contact force, a remote force, not a contact or remote force, and not any of the above. What is your answer for the first one? Only Abhay has given the answer. Yeah, good. So everyone goes with the number 1. Is it a contact force? Let's see. Yeah, Litumi, tell me your answer. Yeah. Oh, yes. Who raised your hand? Yehenia?
First one.
Yeah. Why you call it a contact force? Just give a general idea for me. Yeah, correct. The answer is correct. Okay. Yeah, good. Okay. Let's move to the second one. Given below are four permanent magnets with same magnetic power. When an iron strip is brought towards them, which magnet attracts the iron strips very well? Abhay has given the answer. If you can you just elaborate your answer? What is the reason? There's a property of the magnet that which help it to attract more iron strips. It has more available space, so it can attract more iron strips. Then what can you observe when you float the slice of cork with the magnetic needle on the basin of water? Yeah, X and Y turn to north and south direction. Good. Pamudani, good. Okay, consider the following statements about magnets. Materials which are attracted to magnets are called magnetic material. That is correct. Metals such as nickel and chromium are as well as non-metals metals such as nickel and chromium as well as non-metals such as ferrite are called as magnetic materials. Okay, places of a magnet in which magnetic power is concentrated are called magnetic poles. Ferrite is used to generate powerful permanent magnets. So, yeah, the answer is the second one. Good, Abhay. ACD. The number B is incorrect because ferrite is also a magnet. It's also a metal. Which one is not a reason to lose the magnetic power of a permanent magnet? Aging is correct. Subjected to vibrations with contact with iron nails, subjected to high temperature. Yes, good. The answer is contact with iron nails, that it attracts on the this iron nails and do not do any damage for that. Wrong statements related to storage of bar magnets. Wrong statement, okay? You have to be very careful about the question, that the way that they ask the question. Strap of wood placed in between the magnet. That is correct. Soft iron plate is connected between the poles. Connected between the poles. Yeah. Arrange as North Pole and South Pole are near each other. Yeah. Arrange same poles near each other. That is incorrect. The answer is number 4. Okay. Here, the select appropriate words from the brackets and fill the blanks of the paragraph given below. I will give you a minute if you can complete this. And is there someone who can fill this and read that with me? Read that for our class. If someone can, please raise their hand. If someone has done this earlier, you can just read this out and then we can discuss the answers for this question. Otherwise, just reading by myself and again answering by myself is not working. Okay, can you do that to me? Shall I unmute you?
Yes, teacher.
Yeah, go on.
Materials that show magnetic properties are called magnetic materials.
Good.
The best material to make the permanent magnet is ferrite.
Good. Good. Correct.
To make simple magnet,
Yeah.
soft iron is commonly used.
Good.
The area in which magnetic force exists is called magnetic magnetic field.
Yeah. Correct.
Influence of a magnetic field can be observed using magnetic field lines.
Okay. Good.
The area on a magnet where the magnetic forces are concentrated is known as the magnetic pole.
Good. Okay. Well done. Good. Then what are the, so see that if we can interact like that, the lesson is much more interesting, and it gives you the opportunity to uh, interact with me and ask questions like that. Okay, what are known as magnetic poles? Here also we talk about that where the magnetic forces are concentrated in a magnet are called the magnetic poles. What are the two types of magnetic poles? That is North Pole and South Pole. Explain one method of finding the poles of a magnet in the magnet where the poles have not been marked. There are about 5 methods. You can write. One example is using a compass and using a marked magnet where if the magnet has the poles marked, we can just use that and find the poles of that magnet which has not the poles have not been marked. What is known as geomagnetism? So we discussed that in the unit, and name the following in the diagram. You know that this true north is the line we have here. Let's see whether I can, yeah. This is true north and true south is this, and magnetic south is here, and magnetic north is here and magnetic south is here. Good. Here, what are the two types of magnets by considering the uses of them? Good. Permanent and temporary. Good. What are the differences between temporary magnets and permanent magnets? What is that? Their magnetic property remain for a long time in temporary magnets, and it's only example as an example the electromagnets, their magnetic property fades whenever the electric current is not supplied. Right, two uses of permanent magnets. For what we can use them, we have a list of uses on that. Okay, so you can write two of them. Example, using compass. Okay. Okay, we completed those two lessons. We are giving an interval before that. Let's just keep into the next lesson. Okay, because we have a bit interesting and compulsory that these two units, those electricity and then the chemical reactions, they are a bit complex units, but not much complex, but they have the subject matter from which that many questions are being asked. So we have to be sure to make sure that to study them well. මේවා හොඳට study කරන්න ඕනේ මේ two lessons because they are big, they have materials which can be asked from the for the questions. So an electric current. So from grade 6 from until grade 8 you are learning this about this electricity step by step. So we can now just define this electric current. So this electric current is a flow of electrical charges to a closed circuit. Okay, these electrical charges mean still you are not they are not exaggerating about what are these electric charges. I also keep that hidden because mama දැන් මෙතන එක discuss කරන්න ගියොත් it will get more and more complex. Okay, so the flow of electrical charges through a closed circuit, that is called the electric current. Okay, so in some in a closed circuit like this, if it is not closed, there won't be any electric current. You know that if when you prepare a circuit, if somewhere it is it has been loose, that electric current is not flowing. Even that we use this key in order to control this current. Okay, electric flow. Then this the direction of the current is from the positive terminal to the negative terminal of the cells. Okay, so there is a defined direction for the flow of electric current. There's a defined direction and it flows from the positive terminal to the negative terminal. This is the positive terminal and this is the negative terminal. So it needs to be flown in that direction. Okay, so identifying the direction of an electric current. So in a circuit, how can we identify the direction of the electric current? Can somebody tell me how to identify the direction of the electric current flow? That the electric flow is there. We know that there's a bulb and it has given the light and it's working. So how can we find that in which direction this electric current flows? Raise your hand. This is a good chance for you. So just try it and check whether you have learned that correctly. If that's not correct, I will discuss it and can someone explain that? What can be used to find the direction of the electric current? Something very simple. Good, Bhagya.
Madam, can you hear me?
Sorry?
Can you hear me, madam?
Yes, I can hear. Tell me.
Okay. Here in when we are using a galvanometer or milliammeter or an ammeter,
Good.
when the current is flowing, the direction that indicator is going is the direction that current flows.
Good, very good. And there's a specific quality, there should be a specific quality for the galvanometer or a milliammeter or the ammeter that we are used in order to check the direction. What is that property? That should be that kind of a galvanometer or a milliammeter. Can anyone tell about that? In order to see the direction, this indicator should be at the middle. So we call that a center zero galvanometer. Okay, here also they have not given the zero mark is at the center. So we call that center zero galvanometer and center zero ammeter or milliammeter. Okay, so that can be used in order to identify the direction. If the current flow from this to this indicator go to the bright side. So even using that also, even if we use this, if we use the motor here the electric motor, when we change the terminals, we can find that the direction that it that it rotate also changes. We do this in grade 6 and 7. Okay, so here we are learning more about the electric current. We can measure the amount of electric current that flow from a circuit. Okay, so we are using some units, and there are some subunits, and there's a scale of those, the main unit and the subunit, and there's a symbol, and there are some other instruments, the main instrument and sub instrument that can be used. Okay, so I hope you can see see me in the board. Just give me this. I will do this and give you the interval. Okay, so the electric current we denote that in the amount of electric current. So we denote that in I, and our unit is a ampere. Okay, ampere. If that amount of current is very small, we cannot use this unit ampere. Okay, then we use subunits. They are called milliammeter. Okay, milliampere. This more smaller ones can be microampere or so. So 1000 of milliamperes are equal to 1 ampere. Okay, and 1000 of microampere is equal to 1 milliampere. Okay, you have to remember this. Okay, so the equipment that we use is ammeter. The main one is ammeter. Okay, so that should be double M. Okay, ammeter, and its symbol is A plus and minus mark. This is all for the measuring of electric current. Okay, so that is there. Here they need to be connected in a series. Okay, like here from the positive terminal of the cell into the positive terminal of the ammeter, and its negative terminal into the bulb or the rest of the part in which attached to the negative terminal of the cell, the electric source that should be connected in a series manner. Okay, so that is the way that we have to do. Okay, so I hope you have been joined to the other classes or others for the other subjects also in this Pensala.com. So I hope that you know a little bit about the institute that we are learning. Okay, so in here that we teach all the subjects in Sinhala medium and English medium up to grade 9. So you are going to grade 9 from this year. Okay, so then you are have to shift into the grade 7, grade 10. So from here onwards, if you join with me from grade 9 to continue this journey, I hope that this lesson will be more interesting than this, because we are just aiming the term test. So I have to cover a lot of study, a lot of content in a small time. So when we study leisurely, we can do this process very leisurely and very interestingly. Okay, so now I'll give you a 15 minutes break, 10 to 20 minutes break. So hope you will be back and join with me, because I will be continuing the lesson to read this unit number 7, 8 to 9. Okay, so hope you will be back, and please make sure that you will let me know the most important lessons that you have to cover from unit number 10 to 50, because we won't be able to cover all those things. So please leave a comment in the chat that what are the, and think about it, and after coming back just let me know about that. Okay, so take your break and please come back. Sure. Okay, hope you're back after your interval. Okay, hope that the others will join us. And until that, I'll let you know about our institute. Okay, so we are Pensala.com. Some might have known this and some might just join today. So I will just introduce you a little about our education institute. This is an education institute which is promoting the online learning with much facilities and quality education. So if you can go there, for these days we are doing this seminar series. So starting from the next term, we are going to a new class. So from there, from the February 15th, we are going to start the classes for the new year. So you are going to grade 9 and so you can start the classes from grade 9. So I will let you know how you can work with our institute and learn how with our institute by joining with us. So the first thing that you have to do is just to go to our website. So here, this is Pensala.com. So you can go to the Google and just type Pensala. That means Pensala. Okay, then it's coming this Pensala.com. So you can go there. So then you can go to this. Yeah, you can visit this. Okay, this is the face that you have. Then you have to make a profile here. Here you can see login. There you can go there and add and your email. Here you have given the sign up. Since you have not created a account here, account එකක් තාලම open කරලා නැත්නම් you have to go with sign up. So then you can give first name, second name, then the grade. Now you are going to grade 9 and the medium it's English. You have to give these details correctly and you have to give your email address. You have to remember that after creating, I know that you have a email address. So you have to type it here. Okay, so you have to give you have to put a password and your phone number here. And submit. Okay. Now your account has been formed here. Okay. So after that, you can see all the details about the classes. So here you have access to the timetable of the classes. Timetables and how you have to pay there and the online classes, when will be the online classes. Here the grade 9 English medium. So here you can go there and book this and Here you can find me here and my details here. Okay, so we will put the updated lesson plan here, and after that here you can book the class and join with me for our online classes. And even if you cannot, if it's unable to join the classes, you can go to these the recordings and just go through them and learn that missed classes. Okay, so here by going there you can find this seminar series that if you have missed there, you can just go through them again and again and see that even that is available in the YouTube too. Okay, so you can join with our class. I invite you to join with me and all the for the other subjects too. Okay, you will find this interesting and you will be given separate attention and you will be prepared for your term test and you will get a good chance of learning about these lessons and also practical and also the general knowledge that you have to know as a science student. Okay, so that's all about the institute and how we can continue studying science with me. Okay, okay, let's move on to our lesson. This is where we stopped earlier. So we have to connect this ammeter or milliammeter in order to measure the electric current as a series to the circuit. That's an essential thing. Then we have to talk about another measurement that we take. That is called the potential difference or a voltage of an energy source. Okay, we use in an electric circuit, we usually use cells and some kind of other electric devices, the electric sources. So the difference of electric potential energy, there's a potential energy in between these terminals, that the positive terminal and negative terminals, between them there is a potential energy difference. So this difference of this potential energy is called the potential difference or the voltage. So they have talked about the electric potential energy. You know about this potential energy difference when we talk about the energy transformation in grade 7. Can anyone remember that? Raise your hand if you can tell me the energy transformation happen when the water at a higher level fall down to the ground level. The water stored at a higher level is going to fall to a lower level like in a waterfall. In a waterfall, what is the energy transformation that we can find? Is there anyone? Good, Bhagya. This is for you. Can you tell me? I'm going to write what you are telling. What is the energy transformation?
Potential energy to kinetic energy.
Good. The potential energy is converted into kinetic energy. Okay. So, thank you, Bhagya. And then here, we talk about that there's an energy difference, that electric current is here in the plus terminal or the positive terminal. From the positive terminal to negative terminal, there's a movement of electrical charges. Okay, due to that, there's a difference of this electric potential energy occurs. Therefore, because of that potential energy difference, here is the positive terminal, here the negative terminal. So there's high potential in this end and low potential in this end. So these electric charge, the movement of these electric charges result the movement of electric current to this side. This is that the direction is shown by the blue color mark. Okay, here they have just given a small idea from this diagram. This it's just a clip art. There's a potential energy, higher potential energy at positive terminal. So it's like pushing those electric charges from plus n to minus n. So the current also, that due to that this flow, the current is made from this positive end to negative way. You will learn why this electric charges are from this terminal to this terminal, but the current occurs in the other direction. You will know the reason for that in higher grades. Okay, so this voltage means the difference in the electric potential energy between the two terminals of a cell or a energy source. So the potential energy has the symbol of capital V. Okay. Potential difference has the symbol of capital V, and the international unit for potential difference or the voltage is volt, and its symbol is also capital V, and we use voltmeter in order to measure this potential difference, and the symbol of the voltmeter in a circuit is this. I will show you that. Okay, so the potential energy that is V. So the unit is volt. The symbol is V, and the equipment is voltmeter. Okay, and the symbol of the voltmeter is capital V here, and the positive and negative terminals. This these positive and negative terminals of this voltmeter is also important. This red color gives in red color they have shown the positive terminal, and in black color this is the negative terminal. So we have to join the circuit, this positive terminal to the positive terminal of the energy source or the electric source. Okay, that should be connected in that way. Okay, so here voltmeter is connected. You know that we learned that we have to in order to measure the electric current, the ammeter or the milliammeter should be connected as series for that circuit. Okay, but this voltmeter have to be connected parallelly to the circuit to measure the potential difference between 2 points. If we have to measure the potential difference of this bulb, the terminals of this bulb, we have to connect them parallelly. This voltmeter have to be connected parallelly to that bulb. Okay, so that's same. Here also we have to join them parallelly to this bulb. Okay, and then we are moving on to the resistance. We know that in a circuit, these are there. There should be an energy source. I will denote that in this. This is the energy source, a simple a cell. Okay, then there should be connectors. Sorry, there should be connecting wires. They are the conductors. Okay, so conducting wires and some like a bulb. So there should be there. You know that this is the symbol of a bulb, and there can be a switch, and an ammeter can be there in order to measure the amount of current, and a voltmeter can be joined here to measure the potential energy or the voltage of this bulb, and like that. Okay, so the resistance of a conductor, you know that this electric current is flowing from this circuit. Okay, but while the flow is there, this flow does always has a opposite force. That means it's not leisurely flowing from through these conductors. These are conductors. These connecting wires are the conductors that this electric current flows. Okay, so we call resistance as the obstacle caused by the conductor to the flowing current. Okay, that is by when the resistance of a conductor increases, if this has obstacle in there, if the resistance of the conductor increases, the current flow decreases. This is just a model about that. Here, when it has the same shape and same size, the water flow is flowing in a definite speed. But if it has a bend like this, the amount that can go through this area is decreased. So there's a resistance to flow from there. Therefore, the water flow, the speed of the water flow decreases. So this is the resistance that it gives. So this resistance of a conductor, there are some kind of a resistance. So this conductor is there which disturb the flow of the electric current. Okay, we denote the resistance by capital R and the unit of measurement is ohm. Okay. So all these electrical instruments has a resistance of their own. And apart from them, in order to control the electric current, we can add resistors to the electric circuit. Okay, resistant, we denote that in capital R, and the unit is ohm. This is the symbol of ohm. Okay, and the symbol of resistance is this. Okay, and we use that also, but that is not, we don't use that commonly in our circuits. This is not commonly used. This is the symbol of the resistor. So resistors are the electrical parts that possesses the property called resistance. So it gives that obstacle for the electrical force. So function is to control the current flowing through a electric circuit. Okay, they are used mainly in, have anyone examined electric circuit of a used computer or a remote or some kind of electric instrument? Is there anyone? Raise your hand. There should be someone. Has Patum done that? Have you opened such a circuit and even by a chance, even at school? Usually they are showing in grade 6 also, in the unit number 8, they are showing that kind of electronic circuit. In there you learn about these resistors. They have added these resistors in everywhere. No one has observed it. I can't believe that. Bear has watched that. Okay. So you can find number of resistors in there. Okay. And even some are there, we can change the amount of resistance that it gives. Okay. There are instruments like that. Okay. That's the end of our 7th lesson. So, shall we move on to our next lesson? Yeah, this is it's a bit boring, I guess. Let's see. Okay. Can you see the screen, a video? Good. Okay, this is about the voltage, current and resistance. Okay. Sorry.
Electricity is the movement of electrons. Electrons are charged particles. The movement of this charged particle can be caused to do work. Your light bulb, your bike, your TV, your computer, all are answering the movement of the electrons in our work. They all operate using the same basic power source, the movement of electrons. When we talk about electricity, there are 3 fundamentals we need to understand: voltage, current, and resistance. Voltage is the difference in charge between 2 points. Current is the rate at which charges are flowing. Resistance is material's tendency to resist the flow of charges, also known as current. When we are describing these terms, the common analogy is the water tank. In the water tank analogy, water represents the charges, water pressure represents the voltage, the control current represents the resistance. Let's open the well a little bit. Water starts to flow. Moving the well, this moving water represents the moving electrons. Moving electron flow is then as the electric current. Let's open the well further. We are reducing the resistance. This allows to flow more electrons, the high current. Okay, let's close the well a little bit. The water is still moving, electrons are. We are increasing the resistance. It reduces the water flow. Electron. Increase of resistance cause increase of current. resistance. We increase the voltage, it causes an increase in the speed of motor flow. The amount of water flow in a second is binary. That means increasing the voltage also increases the current. If we decrease the voltage, it goes to decrease the speed of motor flow. The amount of water flow in a second is lower than earlier. That means decreasing voltage also decreases the current. That's the water diagram of electricity. Water represents the electrons. Machine represents the voltage. Control wire represents the resistance. And wire, the water represents the electric current.
Okay. That's what I have to show you. Okay, then let's move on to the questions now. Okay, okay. The first question, I prefer if you give answers for the question, and like earlier, you can get the chance in order to answer some questions. SI unit for resistance is, I'm opening my chat. So, SI unit for the resistance is, that is number 4, it's ohms. The voltage of a car battery is, anyone doesn't know? That is 12 volts. Third one, electric current in a circuit is measured using ammeter. That is correct. The unit of measuring current is ohm. That is incorrect. Resistance is measured using an ammeter. That is also incorrect. We use that. We use resistance using ohm. Okay. Which of the above statements are correct? Okay, we use ammeter in order to, yeah. Vaiha, you have a raised hand. Give me a second.
Answer is A and C only.
For third question. Is it for the third question?
Yes.
There, which of the above statements are correct? First one is correct. You measured using ammeter. That is correct. The unit of measuring current is ohm. That is incorrect. And the resistance is measured using ammeter. That is incorrect. We measure electric current using the ammeter. So the answer should be only A, the number 1. Okay. Good. For the Abel, the first one, the SI unit for resistance is ohm, the number 4, and the voltage of a car battery is 12 volt, number 2, and third one, it's number 1. And the fourth question, the incorrect statements about potential difference is, the positive terminal has higher potential than negative terminal of a drive cell. That is correct. Potential difference can be also named, sorry, here that should be voltage, that should be there. Electric current flows from a lower electric potential to higher electric potential. That is incorrect. It's flowing from the higher electric potential to the lower electric potential. The voltmeter is used to measure the potential difference. So the answer is number 3. For the fourth question, the answer is number 3. Okay. if you want to measure the voltage between the terminals of which position and the if you want to measure the voltage between the terminals of the which position that your voltmeter should be connected between the terminals, this is not needed. The position where that the voltmeter should be connected is which one? Terminals of the bulb. Okay, the voltage of that bulb. In order to find the voltage of this bulb, from how this voltmeter should be connected. Yes, very good. Only to B. Okay, this way that should be position. Okay, in the two terminals of this bulb. The instrument that can be used to identify the direction is a voltmeter, ammeter, center zero galvanometer, and milliammeter. This should be the answer. The center zero galvanometer. Just not, we cannot take the answer as galvanometer. That should be the center zero galvanometer. Okay. So here, the first question, draw the symbolic diagram of the above circuit in the given box. Now you have learned about the symbols. Can anyone draw that and show me? I will just keep discussing the other questions, and I hope someone will draw this and show that to me. There's a problem that here there's a motor. You don't want to draw that, okay? And take this as a, just ignore this motor and take this as a ammeter, okay? Then draw the diagram and let me know, okay? You can raise your hand. Mark the direction of current flow with the symbol of electric current in the circuit. In order to discuss this, we have to draw this and see, okay? So let's move on to the part B. Given below is a setup arranged to find out whether the resistance of a conductor affects the flow of current through it. Okay, whether the resistance is disturbing the conductor's current flow. Nature of the illumination of the bulb and the ammeter readings were recorded where when each piece of nichrome and a copper wire same connected separately to A and B terminals. First we connect nichrome and then copper. When which wire was connected between A and B terminals will the bulb light brightly? Yeah, you might not know this. I'm not confident about this. Whether you know this, you have learned this or not. The nichrome nichrome wire has a higher ability of flowing the current and it has lower resistance. That's why they have been used in the bulbs. You know there's a small nichrome wire in the bulbs like this. In the bulb, like this, they are kind of this there's a wire in here. This is made out of nichrome. Okay, because this conducts electricity very well. Okay, compared to copper wire. What are the reasons for the above observation? This is because the resistance of the nichrome wire is lesser than the copper wire. What is the relationship between the resistance and the current flow of a conductor? That is, when the resistance is high, the current flow decreases. When resistance is low, the current flow increases. Okay. Copy the above circuit diagram and draw the way you should connect the voltmeter to measure the potential difference across the dry cell. Okay. Across dry cells. Okay. Cross dry cells. Okay. Then cross dry cells means we can take this as a unit and place the voltmeter. Then this is ammeter, and then there's a bulb. Yeah. You can connect this. Okay. I leave it to you too. So is there anyone who has drawn this one? No one is there? Kisumi? Abaya? It's okay if you can't do, if it's wrong or if it's difficult for you, just I prefer if you can try that. Okay, I can't waste more time. So for the first one, we can draw that. I will erase this. In there, about the positive terminal and the negative terminal, there we can yeah, we can, if we can take it as a series, we can join it here. If we have to take one by one, then we can do it like this. Okay, if it's to measure the voltage of this bulb, then we can place it there. However, that should be connected parallelly to the electric instrument that we are going to measure the voltage. Then here there's a cell, then there comes the switch, and then the ammeter. Okay, here the positive. Then I told you to just ignore the motor. Okay, so then mark the direction of current flow with the symbol of the electric current in the circuit. This should be the direction from positive terminal to the negative terminal. Let's keep it close. Okay, then to change the direction of the motion of a center zero milliammeter and rotational direction of the motor, what changes that you can do in the circuit? So, in order to change the direction, what we have to do? The current flow is provided by this electric source, which is the cell. If we change the terminals of this and just change the way that we connect this cell into, then this direction changes into the opposite side. Okay, so we have to, the only thing that we have to do is just connect the cell in the other way. Right, two things that you should consider when connecting an ammeter to a circuit. First thing, you should have to connect the positive terminal and negative terminal correctly with the circuit. Then this ammeter should be connected in a series way to the circuit, like a series, not the parallel method, in series one. And this positive and negative terminals, this should be positive and negative. Okay, that is the thing. Name and draw the symbol of an instrument which can be used to measure a small current in a circuit. Okay, that is milliammeter. And its symbol is milliammeter. Okay, so that's all for that unit. Okay. Okay, now we are moving on to the next unit, the changes of matter, changes in matter. From the grade 6, the second unit that we learn is about the things around us. In there, we learn about the status of the materials, that they are the states of matter, the solid, liquid, and gases. So then we continue that into grade 7, and we are talking more about that and very widely in grade 8, changes in matter. Okay, so we know that there are physical changes just by this rupturing that this paper. We can change the composition of that matter. Okay, this is not the composition, the nature of that matter. Okay, so then it becomes smaller. Okay, so but if we take a clay, some kind of clay, and if we give some pressure and make a statue, their nature changes, the shape and the size changes, but its composition does not change. This paper, though it's ruptured into two, it is made up of that plant matter and this paper. Okay, and that statue is, though it changes its shape, it's made out of that clay. Okay, so the composition does not change. But in these chemical changes, if we apply some heat to the paper, this changes the composition of the matter and can make a new substance. Earlier it's a paper, and after that it turns into what? Nethun. Yes, ash. Thank you, Amber. Good. Okay, then it turns into ash. So it's another compost, that it's another type of substance. So this kind of a change happens when these chemical changes happen. Okay, so changes of state as physical changes. Okay, there's an error in the making of the slide. So in these state changes, the solid, by fusion of that, it turns into liquid. Then it's a liquid, by freezing it can turn into solid. Liquid, if we keep supply heat, it vaporize and produce gas. If that gas get condensed, it makes solid. It's liquid form. If the gas form, if solid is sublimated, it produces gas. Okay, if the gas is get condensed, it becomes a solid. So this is a series of a cycle of state changes. Okay, but these chemical changes, there are in a chemical reaction, there are reactants and there are products. This is just a cycle of the same thing. If we take water as an example, here it's ice in the form of solid, and then it becomes water, liquid water, and it becomes vapor. All are the same thing, the states of a same matter. But here, in a chemical reaction, there are some reactants and they are becoming into different products. Take an example as the first chemical reaction you learn in science, that is photosynthesis. What are the reactants? Anyone? What are the reactants of photosynthesis? Hands up if you like to Isali. Can I hear your sound? Your voice?
Yes, teacher.
Good.
Sunlight, water, carbon dioxide. Are
Yeah.
those correct?
Yes. Very good. And what are the products?
Glucose and oxygen.
Good. Very good. Okay. Then, different kind of reactants, a gas, carbon dioxide, and a liquid form water, then it turns into carbohydrates or glucose or sugars, and then produce a gas called oxygen. So there's a big change. So in these chemical reactions, there can be occurrence of different processes. Evolution of gases. Some gases can be produced. Change in color. During this process, colors can be changed. Example, when the heat is given to the paper, then that white color paper turn into black color or ash color ash. Okay, then change in temperature. Okay, when we provide heat, that can if we provide heat to a metal, solid form of that can change into another type of liquid form. Okay, formation of precipitates. It can form precipitates in grade 7. If you can remember in 17th unit about nutrients, in order to identify the sugar types, we do a test called Benedict's test. In there, we show that the formation of precipitate which has the brick red color. So, we have not used any solid there, but a precipitate is formed. Production of sound or light. Okay, when we provide heat just to a paper, it gives light, and if we add sodium, part of sodium into water or potassium into water, it gives a pop sound. Okay, then production of an odor. There can be different odors in there. Ambe, I'm not clear about the question that you're asking about what. Okay, the law of conservation of mass. That means the speciality of a chemical reaction is that its total mass does not change within this chemical reaction. Okay, the mass of the reactant remains the same. That means we learn that in a chemical process, reactants are there and products. Okay. If we take the reactants, first we about the read that in photosynthesis, the amount of carbon dioxide and water. Okay, carbon dioxide, the total mass and the total mass of that, and the produce glucose plus oxygen. Okay, the mass of them, this mass is equal to these masses are equal. If we do the calculation, or if we measure them, this the total mass of these reactants are equal to the total mass of these products. Okay, you got it? I know energy is produced, but we can't measure that. There's no mass in energy. So the products, they have the equal mass as the reactants. Are you clear? Good. Here we are talking about the chemical changes. Okay, so the first one is combustion. Okay, so the combustion means the chemical change that occurs by releasing thermal energy and light energy. Okay, in the reaction, only the thermal energy or light energy is produced. Okay, here in the environment, we can categorize all the substances into two: combustive substances and non-combustible substances. Okay, in talking about this one, we have all the firewood and all the gases and like that, they are combustible, and here they are not. They begins combustion in the air at its ignition temperature. Okay, there's certain temperature that they start this combustion process. That is called the ignition point or ignition temperature. Okay, so when we keep supplying this, when this chemical reaction happens, there's a certain temperature where these substances start releasing thermal energy. That temperature is called the ignition temperature. Okay, so in order to happen this, in order that some substance undergo this combustion, there are three major things are needed. There should be a combustible, sorry, I'm bad in pronouncing this. So that substance should be there, a substance that can undergo combustion. Okay, that should be there, and heating this substance to the ignition temperature. Heat should be produced, provided up to that ignition temperature. And also, though this is supplied, it's not enough. In order to have this combustion to happen, there should be oxygen, the support of combustion. Okay, in order to occur this combustion, the support of the combustion, which is oxygen, needed to be there. Okay, so this total process, this we are calling that a fire triangle. Okay, so there should be heat, there should be the presence of these substances, example, it's fuel, and the temperature, that means the heat, and the oxygen should be there in order to occur this combustion state, okay, process. So, fuels. There are three types of fuels: solid fuels, liquid fuels, and gaseous fuels. Okay, you know examples for that. And here we are doing this practical in order to see the combustion of fuels. Okay, so here so in the candle wax is used here, and we have given we are using them as the energy source here. So the combustion of wax, then that is a reactant, and there's a chemical reaction happening, and the products are coming out from there, and they are going into here, and they have added anhydrous copper sulfate. Anhydrous means, is there anyone who know about this anhydrous, the meaning of anhydrous? Kenushi, do you know that? Dinuka, anhydrous. Tisumi? Okay, so Tisumi? So one, okay. Anhydrous means the copper sulfate that lacks, which is not, we do not has water. The water content is removed from this copper sulfate. Yeah, no water, good. Then, and then it is linked with this lime water. Okay, the aspirator means they are taking the, they have taken the all the air out from this container. Okay, so all the air that come from the gas come from this one is getting filled for this area. Okay, so we can find that white anhydrous copper sulfate turn into blue color. Usually the anhydrous copper sulfate is in white color. Normally we can find copper sulfate in bright blue color. But after removing the water, we can find it in white color. So after a while, this anhydrous copper sulfate turn into blue color. And the lime water also turn into milky color. So the reason of this is, this emits carbon dioxide gas. That is the reason the lime water turn into milky color. And also this anhydrous copper sulfate turn into blue color because this also emit water vapor. Okay, so we can find that the water and carbon dioxide are produced and they are the products of combustion of wax, as an example. So in combustion there are two type of combustion, that is complete and incomplete. So for the incomplete combustion, the products are carbon dioxide, water and high heat. But in incomplete combustion, you might have heard this, I will tell you. Carbon dioxide and water is produced. Apart from them, carbon monoxide is produced, that which is a harmful gas. And some unburned carbon particles can remain. So we tell that we have to clear our engines of the vehicles well, otherwise the fuels can undergo incomplete combustion, which can emit carbon monoxide and unburned carbon particles, which lead to the air pollution. Okay, so in a candle flame and a Bunsen flame, you can find these areas. Okay, you in a candle light, have you seen the blue zone? candlelight, it also always gives a kind of a orange color, orange and yellow color here, an orange color here, and at the bottom it gives a blue color, blue zone, and there's a non-luminous zone in the middle, and the luminous color, luminous orange to yellow color area here, and there's a outer zone which cannot be visible. And but in Bunsen flame, that the flame is mostly blue color. Okay, there's a dark blue zone in the middle and a light blue zone is there. So this is an example for a complete combustion, and here it's a incomplete combustion. Okay. So we say that if a Bunsen or our gas cooker, if it gives a yellow color, flame, we have to repair it and make it make sure that the complete combustion take place. Okay, so then the second chemical reaction that we are talking is tarnishing and rusting of metals. This can be commonly seen in areas like in our coastal area, since there are many salt content in the air. So what we can see, what is we will this time is for us for what is this tarnishing? Tarnishing. Have you seen them? Fatima? This tarnishing? Have you observed about this tarnishing? Okay. This is called, you know that normally metals has their own feature of a shiny surface. Okay, when we bought them from the market, they have a very shiny surface. Even in grade 7, can you remember that for a for a concave mirror, we took this as an example, the spoon, the outer surface and inner surface of a spoon, a concave and convex mirrors. Okay, because they are very shiny surfaces. So by exposing them into air for a longer period, their shiny surface start to tarnish. Okay, like it here. And almost every metals undergoes this tarnishing. And if this happen for a long time, okay, if this continues for a long time and some other factors in the environment also facilitate this, that leads to rusting of iron. Okay, here the rusting has been occurred here. And here the practical is to find the factors essential for the rusting of iron. Here, by this, they have added a coconut oil layer in order to prevent the air coming to the this reaction area. They have added boiled water and coconut water to this and use clean air nails here. Okay, and then we have not added coconut oil layer in here. So the observation comes that these iron nails quickly getting rusted compared to these two, and even compared to these two, this one get rusted very late, become very late. What one with cold water, it rust earlier than the one in boiled water. So they get the idea that by exposing to air, that exposure to the air facilitate the rusting of iron. So by that conclusion, we move on to the next one. So here we have put a cork stopper, and the iron nails have been placed inside those ones. So half of the iron nails are outside and half of them are inside. We place them before that we add calcium chloride crystals to the test tube. The function, does anyone know the function of calcium chloride crystals here? Please raise your hand. Yeah. Wait. Can Isali tell me? Can you please tell me, Isali? Oh, Ehen?
Absorbing moisture.
Sorry?
Absorbing moisture.
Yeah, good. It can absorb moisture. Okay. Since there was air contained in the inside the tube, that moisture can be absorbed by this calcium chloride crystal. That's a feature of them. Then there are no available moisture inside, so the water vapor is not there. So they have added some bags from here and make sure that no air comes inside to this this inside of the tube. Okay, this is exposed to the air. So then we can find that these side of these iron nails get rusted, and these remains non-rusted. They do not get rusted. Okay. Then the next one is here. We are adding some cotton wool at the top, and this is a control experiment. In here, we first add iron fillings and close that using this moist cotton wool and place both in the water bath, okay, as inverted tubes. Then what was happening is that the water level rises in only this tube. Okay, that is because these iron fillings can anyone tell me about why this is happening? Why this water level rises? Can someone raise your hand? I need someone of you to. So we know that the water is needed for the rusting process by here. So they have, by adding moisture cotton wool, they have provided that water to the iron fillings. Okay. So here, this air contains oxygen, and the air is there also, but for the process of rusting, the oxygen amount that is here is being used for the rusting process by the ions. Then that oxygen amount is becoming lower and lower. In order to fill that amount, the water levels come up. So by this, we can conclude that oxygen and water vapor are essential for the rusting of iron. Okay, so in order to protect iron from rusting, we normally galvanize them or paint them in our general use. And the next chemical reaction type is neutralization. So you know that the best example for this is the medication that you get for the gastritis. Okay, I will tell you it later. So here they have added hydrochloric acid and here sodium hydroxide, and they have mixed them and formed sodium chloride solution. And then separately they are checking them using these indicators. So when they add blue litmus into hydrochloric acid, it turn into red. That means this is an acid, so it turn into red. And when we add blue litmus to sodium hydroxide, it remain blue because it's a base. When blue litmus is added to sodium chloride, it also remain as blue. Okay, there's no change in there. When we add red litmus to hydrochloric acid, it's red. pH, it's less than 7. Phenolphthalein, it's colorless. And as a base, they have the qualities as greater than pH 7, pink color for phenolphthalein. When we examine that using these, blue litmus remain blue, red litmus remain red, and pH paper, it has the pH value of 7, the color of pH 7, and the phenolphthalein, it's colorless. So, by mixing them, the mixture has become neutralized. That is why they are showing these characteristics with the indicator, acid-base indicators. So this is what happened with your medication for gastritis. Okay, so means base magnesium hydroxide neutralize the excess hydrochloric acid in the stomach. You know that there's an acid form. The acid is formed from the outer cell layer of the stomach. It's extreme, and that gives a acidity to the stomach, and that can damage our outer cell layers if it concentrated a lot. So we take this magnesium hydroxide containing liquid or tablets, and that can neutralize the excess hydrochloric acid and make this compound and make it neutralized. Okay, so that's the end for the of the grade 7, sorry, the unit 8 of your lesson. Okay, let's quickly discuss our questions. Sorry, I have messed it up with this question. Just ignore that. The second one, which cannot be observed during a chemical change. Please keep giving your answers in the chat. Which cannot be observed during a chemical change. Change in state, emission of heat, emission of gas bubbles, change in color. Yeah, the second one. Which zone contains unburned wax vapor? Unburned wax vapor. Which zone? here the luminous zone has this unburned wax, so and especially in the outer zone. No one keep giving me answers. Unburned wax vapor is there in the zone of A, which is used during electroplating, that is the chemical product of electricity. What can you use? Observe after the given setup is kept for few minutes. The disulfide water salt with condensed the membrane. You can just keep that. Okay. Can you keep doing this? Can someone just do this and tell me? Fill these blanks and read me. From that, we are going to end the lesson today. And please, as I have told you, just if you have a specific unit that you need to cover and talk about, discuss more, please put that in your chat, mention in your chat. No, there's no one who can is there. If someone is there, please raise your hand. If someone so it seems no. Okay. The transition of a substance from the liquid state to solid state or is the products of combustion are carbon dioxide and water vapor. Change of a liquid into gaseous state is two major factors affect to rusting of iron are oxygen and water vapor. Okay, like that you can do these, you can answer these things and just correct them using your textbook. So we are going to end the unit here, the discussion here. And since you have not mentioned any units that you have to cover, I will keep doing that. I will select my own lessons and try to do that in the next class. So please join with me for the next class, and I hope that you will be there for the lessons starting from February 15th for the grade 6. Okay, thank you for joining with me, and study well and prepare for your third term test.